Space exploration is something that I've been obsessed with for a really long time, and when you actually start to think about space, it's hard not to get excited about it. For thousands of years, humans have looked up at the sky and dreamed about the stars. And it's only very recently that we actually started to explore space ourselves. And we've come a long way since the first astronauts. New technology has made space exploration more accessible than ever, and every day we make a little bit more progress. Humans have been working on space technology for a couple decades now. Since the moon landings, we've built orbiting space stations, sent rovers to Mars, and even launched probes outside of our own solar system. As of the making of this video, 7 people are in orbit on the International Space Station. But working in space can be very challenging. There's no oxygen, no gravity, extreme temperatures, and dangerous radiation. Astronauts need to stay in very advanced spacecrafts or wear specialized suits just so that they can survive in space. Luckily, we have another way of reaching out into space to help our astronauts. Some of the best and brightest scientists and engineers around the world have made incredible achievements in the space industry. But they've only really scratched the surface. There's still so much to learn and build and discover. And hopefully by the end of this video, you'll be as excited about space as I am.
Hi, my name's Emma and I'm a member of the Queen's Space Engineering Design Team. Our team loves learning about space technology and building robots to compete in competitions. Right now, our team's working on 3 different robots: a Mars rover, a mini satellite, and a scientific experiment that is going to be mounted on a high-altitude balloon. One of the challenges we face is figuring out how we're going to power these robots for a long period of time without them being plugged in. Like many other space robots, our team relies on solar panels so that we can convert the solar energy into a usable source of power. It's both renewable and almost accessible anywhere in space. When our team's not working on our robots, we've been collaborating with the Queen's Connection team to teach you guys a bit more about our projects and hopefully give you the opportunity to work on some of your own space missions.
Hey, I'm Varnika, a member of the Queen's Space Engineering Design Team. Sometimes we create robots to help us conduct experiments in space-like conditions. Our balloon experiment is one of these robots. We've been working closely with the researchers at Queen's University to test new orientation-determining software. Our experiment is designed to track the Earth's horizon at very high altitudes and record video data for further analysis. It has multiple cameras, a communication antenna, and several mini-computers all contained in a protective case. The balloon that we're mounting will fly up to 30,000 meters above the ground over the course of 3 hours. We need to make sure that it will survive the high-altitude conditions and stay powered on remotely the whole time. To make this work, we're using lithium-ion batteries and 2 solar panels to provide a source of electricity in case they run out. One of the coolest parts about working on this project has been working with people like Dr. Fissel, a researcher in the physics department of Queen's University. Like Roberta Bonder, she's done some really cool work in the space industry, and is the reason why we get to build our balloon robot.
Hello, my name is Laura Fissel, and I am an assistant professor and astrophysicist at Queen's University. As part of my research, I work with international teams of scientists to build balloon-borne telescopes. These telescopes are very large, they typically weigh more than a car, and are lifted to about 35 kilometers above the ground by giant helium balloons, which are about the size of a football stadium when fully inflated. Our goal is to look out and study our galaxy in infrared light, which is mostly blocked from telescopes on the ground by the Earth's atmosphere. We can use these infrared images to study regions of the sky where new stars and planets are forming, and therefore perhaps learn something about how our own sun and the Earth formed billions of years ago. One problem that we have, though, is trying to figure out where to point our telescope on the sky. And for that, we need some sort of a reference point to tell us where the telescope is looking. The QSET team's experiment will test using the Earth's horizon as a reference point, and I hope to use the results from their experiment to build better and more powerful balloon-borne telescopes in the future.
You're the minds of the future that will become part of the next generation of scientists, engineers, and astronauts. We're really excited to see your designs and ideas. Who knows, you might just end up working at the Canadian Space Agency, NASA, or SpaceX one day.